Hello, everyone. I'm Geneviève Paget, and I'm the president of the Queen's Montreal Alumni Branch. On behalf of the organizers of this event, I would like to thank you all for joining us tonight for the Casgrain lecture, which this year is focusing on the topic of artificial intelligence, or AI. I'd like to begin with acknowledging the history of Montreal. So Montreal is situated on a traditional territory of Kanien'kehá:ka, a place which has long served as the site of meeting and exchange amongst the many First Nations, including the Kanien'kehá:ka, the Haudenosaunee Confederacy, Huron, Wendat, Abenaki, and Anishinaabeg. We recognize and respect the Kanien'kehá:ka as the traditional custodian of the lands and waters of this place. And now some technical notes before we begin our program for today. First, you'll notice that the event is recorded, and a video of the event will be posted very shortly on demand through the Queen's Alumni YouTube channel in a few days. As you will also have noticed, we've enabled the Zoom live transcription feature. So if you'd like to remove it or hide it, you're invited to go through the live transcript button at the bottom of your screen. So tonight we invite you to share feedback and comments through the chat function. And if you'd like to submit a question for the panelists, please do so using the Q&A feature on your screen. You can submit your questions at any time during the event. They will be answered in a Q&A portion that will be in the last portion of the evening. So before we begin, we have some really special guests with us tonight. So we have Roger Casgrain, COM80, who's a loyal supporter of the Queen's and a champion of the Montreal branch, along with his wife Colette Charret, Psi82, who's not with us today. They're both recipients of the branch highest honor, the John B. Sterling Montreal Award, which is awarded to the makers of Queens and which honor their outstanding contributions to Queens and Montreal community. Their commitment to connecting Montreal alumni with each other and with Queens is what inspired this event. I'd like to welcome Mr. Casgrain to say a few words.
Merci, Geneviève. Thank you, Geneviève. So, a warm welcome to all of you on behalf of my wife, Colette, and I. We're gathered today in this great university, which is Queens, to discuss artificial intelligence. The fourth industrial revolution has begun, and it already has, and it will continue to have major impact on our daily lives. Specifically, it has impact on each and one of us, on our families, and our communities. That's why we're fortunate to have a panel of outstanding experts on this topic to enlighten us on the many implications that AI will have with our daily lives. And more importantly, that's why we need to continue supporting the university and all of its ecosystem. See, if AI is to improve doctors' diagnosis of patients' health, if AI is to help better forecast natural disasters, such as our friends in BC are suffering through right now, if it helps to better understand the impact on human beings and how best we can help them to transition to this fourth industrial revolution, such as topics as universal income. So it's crucial to have researchers, knowledgeable academics, people at the forefront. And that's what Queens does. And that's what we as a community, as alumni, need to continue as times are more and more challenging for all of us, for the university, and for the changes that people have to live them. That's why my wife, Colette Charret, and myself have been doing for years, and we continue to do. And that's why we invite you to help us and help all of us to make Queen what it can be and what it should be. That is, help us through these major changes that are affecting our everyday lives. So without further ado, I'd like to pass along somebody that, la parole, le bâton, somebody that's very important to the university. Lee Kaelin, Madame Lee Kaelin, Arts 92. Specifically, she's one who takes care of us, all of us, as she's a assistant vice principal, associate vice principal, sorry, alumni relations and annual giving. Please welcome. There you are. Thank you.
Thank you very much. Thanks for that lovely introduction. I want to start by just saying I'm so happy to be here. It's wonderful to be with so many alumni from Montreal and around the world, connecting, at least virtually at this point, after so long apart. As some of you may remember, this event was originally going to take place in the spring 2020 in person. Obviously, a lot has changed since then, but as things were canceled in early 2020 because of the pandemic, we haven't been able to gather, but we're slowly beginning to see our lives return to normal. I want to highlight a couple of the many professors and researchers who have been really working hard on covert efforts here at Queen's. You may be familiar with some of these names. In particular, we have an infectious disease expert, Dr. Gerald Evans, who you've probably seen being interviewed on CBC or CTV. He's been helping the public understand the latest vaccine study or some of the COVID news that's going on. Some of you will have read in the alumni review a profile that we had on Professor Troy Day. He uses mathematical models to predict the spread of COVID-19, and that allows the Ontario government and the officials to have information that is extremely important in making their health policy decisions. We're incredibly proud and grateful of all of the Queen's individuals working in this way and all of the other Queen's alumni, staff, and faculty on the front line. Speaking of thank yous, I'd like to take a moment to express my gratitude to some key alumni and donors who are with us today. Specifically, I would like to thank Roger, who introduced me, and his wife, Colette, for their ongoing leadership and generosity and support of the Montreal branch. I also want to take a moment to congratulate the Montreal branch under the leadership of Geneviève for gathering this panel of diverse alumni and faculty expertise on AI. I know this is going to be a really, really interesting discussion tonight. The most important thing that I wanted to tell you today is a thank you to all of you who are watching. We have at Queen's the benefit of having a powerful and close-knit community of alumni in more than 150 countries, all because of individuals like you. Our community is strong because of the volunteers who organize networking events, our reunion celebrations. They make sure to be in touch with classmates and club members and team members and come together at least every 5 years. We're strong because of the volunteers who connect with our students in different ways, providing mentorship and many, many other things. We're also strong because of the donors who support us in a variety of ways: student financial aid, groundbreaking research, and all kinds of other initiatives that will have an impact on all of our lives, from the students at the school to the world in general. Even coming out here today, celebrating Queen's impact and connecting with other alumni helps to strengthen our community and to strengthen those Queen's bonds. So I wanted to just thank you wholeheartedly for continuing to share your tricolor spirit with us, with our students, and with each other. We have a lot to be proud of. I'm extremely impressed with how we've managed throughout this pandemic. So on that note, I'm looking forward to the fantastic panel that we have ahead, and I'm happy to turn this virtual podium back over to Geneviève. Thanks, Geneviève.
Thank you, Lee. It is now a pleasure for me to introduce you to Stephanie Kelly, Com12, MMA 17, PhD 22, our moderator tonight. So Stephanie Kelly is a final year PhD candidate in management analytics at the Smith School of Business at Queen's University. Her research focuses on ethics of analytics and artificial intelligence in financial services. She uses methods from management analytics and organizational behavior to understand the causes and prevention method for AI ethics challenges. Currently, she has active projects on AI ethics codes of conduct, gender bias in fintech lending, and algorithmic explainability. She recently co-authored the IEEE Trusted Data and Artificial Intelligence System Playbook for Financial Services, a guide for financial services organizations to build fair, accountable, and transparent data and AIS practices. Prior to starting her PhD, she worked in various marketing and sales roles within the consumer packaged goods industry at Reckitt. She has a Master of Management Analytics and a Bachelor of Commerce, both from Smith School of Business. Over to you, Stephanie.
Thank you so much for the lovely introduction, Geneviève. I'm very happy to be, well, virtually here with you all. I'm a little bit further east than Montreal. I'm in Halifax, but happy to be here. So to get us started, I am going to introduce our three panelists today that will be joining me. So we have us first, Dr. Ali Etimode, and he's the Mitchell Professor in AI for Human Sensing and Understanding. Hi, Ali. He's an assistant professor in the Department of Electrical and Computer Engineering here at Queen's, and he leads the Ambient Intelligence and Interactive Machines Lab, and also a member of the Ingenuity Lab at Queen's. So sounds like you're quite busy with the various labs. His main research areas are machine learning and deep learning, focused on human-centered applications with things like wearables, smart devices, and smart environments. So our second panelist joining us is Dr. Amber Simpson, who is an MSc 02 and a PhD 2010. She is the Canada Research Chair in Biomedical Computing and Informatics, and of course, an associate professor at the university, jointly appointed at the Department of Biomedical and Molecular Sciences and the School of Computing. So it's kind of a unique combination. She's the director of the Center for Health Innovation, which is a joint center with Kingston Health Sciences. Of course, Queen's is her alma mater. She's recently returned here from a faculty position at Memorial Sloan Kettering Cancer Center in New York. Dr. Simpson is also an American Association of Cancer Research and Pancreatic Cancer Action Network Award holder and a charter member of NIH Study Section, which recognizes her innovations in biomedical research. So a very unique group of our panel tonight, rounded off by our industry expert, Beth Quinton, who's Psi 98. And Beth is the Managing Director, Enterprise Data and Analytics at Air Canada. So you can see there from her lovely background. I have to admit, I've not been on a flight since the pandemic, but I'm sure you'll have lots of things to tell us about. So Air Canada's mandate and Beth's mandate there is to enable data-driven decision-making across the company with an aptitude, I guess, for math as an engineer, leadership. She's had some pretty unique career paths so far. So right now at Air Canada, Beth and her team are responsible for data strategy, data management, engineering, data governance, BI, and analytics. So really the whole slew of AI and analytics aspects. And of course, Beth holds a Bachelor of Applied Science and Electrical Engineering from Queen's, as well as an international MBA from Rotterdam School of Management in the Netherlands. So if I could have all my panelists up on the screen. First of all, thank you for joining us this evening. To get us started, Ali, can you start us off with a definition of artificial intelligence for our audience?
Yeah, sure. First of all, great to be here and in this panel. So AI is any piece of software or code that would give us the impression of a thought process or logical decision making could be categorized as artificial intelligence. The most probably rudimentary or classical version of AI would be just a series of if-else statements. If something happens, then do something, and that's how we used to program machines, years ago. And a little more sophisticated than that would be to create a data set, for example, of actions and outputs, so that when an agent, for example, wants to make a decision, could search through that data set and make that decision accordingly. And that would be slightly better than the if-else statements that we were using before that. And now with this wave of deep learning that's happening, we use these very advanced models or deep neural networks that learn a relationship between input and output data through lots of iterations. So they try to understand a hidden relationship between the inputs and the outputs. And that's what we mean by AI these days mostly.
That's great. I'm sure you can tell us a lot more, but to get things moving, I guess let's go back to you. Can you tell me a little bit about how you use AI in your research?
Sure. So we use, the focus of my research group is to use AI and machine learning and deep learning to understand humans. So our goal is to develop models or algorithms so that devices could understand their users. And our logic is that if we are able to do that, we can build smarter and better devices so that they can interact with us better, more intelligently. They can customize themselves to our needs as opposed to the other way around. So we want to flip that paradigm if possible. So far, it's up to humans to understand machines and learn how to use them and adjust ourselves to them. And what we think is that if machines can understand people, if they understand who people are and what people are doing and how they're feeling, they can adjust themselves to humans and create a better user experience and in general just be better products in general. And besides this enhancing the quality of experience, we also think that these kind of devices would have implications beyond just a human computer interaction quality. It could also have implications in security, for example, in safety, and in health monitoring, for example, with wearable devices. If devices are able to monitor people's biological signals or their state pervasively 24/7, they could provide a lot of good insights around health and mental health and things like that. And in general, that's the focus of my research group at Queen's.
Great. Amber, maybe you can pick off of that kind of the health side. I know obviously working in the biomedical area. Can you tell us how you're using AI in your research?
Yeah, so Ali talked about humans and their interaction, but I like to think of it as the interaction of diseases and AI and humans and diseases. So we do things like try to predict who will respond to a chemotherapy in cancer therapy. So a good application to think through. So if you're a cancer patient and you go to the hospital, this is how you get treatment. So we will try one different type of chemotherapy. If you fail that, then we will switch you to a different one. If you fail that, we'll switch you to a different one. And this is how we do it, right? We progress through these series of types of treatments and hope that you'll respond to them. But the hope with the work that I do is that we would be able to say, okay, we know based on digital models that you'll respond better to this chemotherapy or to this immunotherapy, to be able to optimize that treatment strategy. We had a nice write-up in the Gazette this week, actually, where we looked at 400,000 CT scans. So these are the medical images that get taken of you routinely when you go to the doctor for your cancer treatment. And we used AI to do something that humans absolutely can't do at all, and that's to study all 70,000 patients that were in this cohort. So we, AI, one thing, people talk about it replacing humans. I think COVID has taught us that it's not going to be replacing humans anytime soon. But I like to think of it as a way that we can augment humans and do work that humans can't do. And that was what the Gazette article focused on. So could we study cancer across the entire population using rich data in a way that's not really been done before? So that's what I like to do. I like to use health data primarily for cancer, but now for COVID as well, because we've all become COVID researchers and COVID experts to some odd degree now. To try to influence how patients are treated in their lives.
That's great. Thank you. So, I mean, probably not a COVID expert, but working in an industry that's most definitely been impacted by COVID, Beth, how are you using AI and perhaps even analytics at Air Canada?
Thank you, and good evening, everybody. So I think, coming at it from the industry perspective at Air Canada, we look at and we've been investing and we'll continue to invest in data all the way from, kind of literally just descriptive reporting all the way through to more and more advanced analytics, all the way up to artificial intelligence. So kind of two use cases to bring it to life a little at Air Canada is we've got on the operational side, we use AI on our maintenance. So our scheduling, we built sort of a scheduling assistant and optimization tool that includes tasks that are based on predictive failure rates and based on locations and based on different priorities to integrate into building us a way to optimize our maintenance schedule as we run through our operations in real time as things change and whatever, a certain plane wasn't able to get to where it needed to get to because we've had to swap it out. And so then what are the implications in order for our decision makers on the operations side to continue to ensure that our maintenance is top notch, at the same time making sure that our fleet is as much of it is available as possible. The other side of the business is more on the commercial side. So as I'm sure everybody can imagine, prior to the pandemic, we used a lot of forecasting models based on seasonality, what happened last year, demands that we're seeing, knowing, we call them booking curves of expectations of when people book throughout the year. Well, with COVID, all of that goes out the window. So we've had to build new revenue optimization models and demand forecasting models that are, that include differences in things like we call no-show rates. So people's likelihood to buy a ticket but not actually show up. Now there are, additional testing, additional conditions they need to have. So those kinds of things need to be brought into our modeling. So those are kind of two examples of how we use AI at Air Canada.
Thanks, Beth. So to change gears a little bit, we've had some great examples of how you're using AI, either in your research or in your organization, but let's shift a little bit to perhaps kind of the dark side. What are some of the challenges that you have faced either in your research or in industry? Essentially, what are the barriers that you've had to overcome using AI? And perhaps Amber, Dr. Simpson, you could get us started.
Sure. So there's obviously the ethical implications. And we've seen this in COVID-19, right? That the data have really shown that there's a group of people that by and large do not benefit from AI or from sort of these computational models that we develop. And that gap has widened during the pandemic. I think another real challenge is availability of data, certainly for the work that I do. And actually Queen's is a huge leader in this now. So during the pandemic, the Ministry of Health in the province of Ontario started the Ontario Health Data Platform, and that platform is available at Queen's. So it's actually at Queen's in our Center for Advanced Computing. And a lot of people don't realize that a lot of the health data in Canada is at the Center for Advanced Computing, and they don't tell people because then that leaves them open to attacks. But it's been tremendously amazing to get all of this health data. Because I will tell you that this is not the case. This is certainly not the case in the US, and that was part of the reason I moved back to Canada. And it's not the case in most of our other provinces. We don't typically have access to our health data, and it's certainly not a complete health record like we are now getting in Ontario as a response to the COVID-19 pandemic. That's super exciting. And I think related to data access, so there's the democratization of access to data, but there's also the democratization of access to compute power. So what we've seen in the big companies is that the big companies just vacuum everything up all the time, right? And so I do something called Grand Challenges, where I release medical data publicly for groups to work on to try to benchmark different algorithms and things like that, and really try to move the state of the art in the field. But what we find is a group like NVIDIA, for example, who are, they're the people that made GPUs, which do all of this deep learning AI stuff, right? So those folks can do something in a day that it takes an academic a month to do because of compute power, because they've got so many computers. And so that's something else that's changed. So the Ministry of Health also bought us a compute cluster, but we still have issues at Queen's with getting access to good, high quality computational power. And I see Ali's nodding his head because he knows we're constantly running out. It's constantly a fight. Where do you put the data? So once you get the data, where do you put it, and how do you actually have enough computer computers to crunch through it. It's a real challenge, and the companies are winning.
Got it. Ellie, I'll come back to you in a second, but Beth, maybe you could tell us some of the struggles or challenges of AI and analytics at Air Canada.
Yeah, well, interestingly, there's some similar themes. Certainly, you know, as it pertains to, in our case, like access to data is more making sure that we have the analytical platforms to be able to do the data science and whatnot. Is, you know, in some areas we have it, and others, you know, we're still building the foundational pipes, if you will, off our source systems into our analytical environment. So, you know, there's across the airline, I would say there isn't a deep understanding of data governance, you know, environments and how that, you know, architecture and how that'll work. So people hear AI and they hear about it, and so then they're sort of saying, well, can you just do this for me? And it's like, well, there's quite a lot of foundational work and investment to get to a place where we actually can do the kind of modeling and to get to the deliverables or the outcomes. I think the other area for us is on attracting and retaining top talent. So we, you know, being headquartered in Montreal, and we have access to great universities here, plus all of our alumni, Queen's included. You know, our connections, we're always trying to attract great candidates, which we are able to do, but it's a hotbed right now. So people come, they work with us, they love, you know, they like the data, they like the fun, cool tools, and then they sort of say, oh, you know, I'd like to try something else. And so retention has been, you know, a challenge. Because you know, and it's the thing that I use or we use the most is, well, in addition to just the excitement of working for an airline, which I hope has appeal, but also is the ability to have a real impact. So you can have a, you know, we're building models that we will literally determine which planes or which routes we're going to put in place 2 months from now. And so I think those are the kinds of things, you know, kind of newer people out of school feel and like, because they can see their direct impact on their work, sorry. Yeah.
Got it. Yeah, it's definitely a hot area. I know the graduates of the MMA and MMAI program are always grabbed up pretty quickly.
Yeah.
Dr. Etimode, challenges, barriers to overcome working with AI so far.
Yeah, so definitely I want to second what both previous speakers said. 100% GPU power and compute power is a big bottleneck. We've spent, you know, hundreds of thousands of dollars over just a few years on compute power, and we're not even there yet. So that's something we're constantly negotiating and looking for and trying to get resources. And then also retention. And again, it is definitely another big problem. We, you know, a lot of the top candidates who, you know, we want to work with as graduate students or postdoctoral fellows can easily get jobs at big companies and make, you know, 8 to 10 times what they would make in the university, and it would be extremely difficult to retain them. And so definitely those are two of the challenges. I wanted to add a third one, which is, it's not a particular problem I've dealt with, but in general, I think it's a problem that the whole field of AI would deal with as a whole. And that is the fact that, you know, AI is just like any other tool. You know, some say AI is the new software. So let's think of it as just software 20 years ago. It could be used for good purposes and making lives easier, or it could be used for hacking into a bank, for example, or hacking into an airline and messing things up. So it definitely, you know, could be used for bad purposes, and it's really important and also challenging to try to find the right applications to work on. And I'll give you an example on one of our work that I'm particularly proud of in this domain. So, you know, deepfake technology, the very famous new tech based on AI that takes, you know, one person's audio and puts it on someone else's face and makes them do things or say things that they hadn't done. And that could be used for really, really scary things, both from a personal perspective, but also in politics, for example, right? It's a very dangerous tech in the wrong hands. What we were able to do, we were able to actually develop a new deepfake technology to take PPG signals. PPG are the signals that your Fitbit or Apple Watch collect. They're the simple waves that every time blood pumps in and out, there you go, exactly. Every time blood comes in and out, you get that wave, and then they count those waves, and that gets your heart rate. What all cardiologists are after is another tech called ECG, or electrocardiogram, which is the one that they put sensors on your chest, and you lie on the bed, and they collect your ECG. That's the real good stuff. That's what they use to detect cardiovascular diseases. So that's the elusive, expensive signal. And then we have the PPG, which is the cheap, $4 signal. You can buy the chip off of Amazon and build it with $3 to $4. So we use actually deepfake technologies to convert one to the other. We took the cheap signal PPG and we developed a new deepfake model to convert that to ECG. So we're hoping that that could actually be used to detect cardiovascular diseases with a very cheap technology, 24/7 in pervasive monitoring format, and especially in low-income countries or remote locations where they don't have access to ECG technologies necessarily. So it's really important for the field for also people who are investing in the field, but also people who are doing work in the field to see both sides of this AI thing that could be used for messing up elections and creating, revenge content for people, but also to save lives with something as simple as deepfake technologies.
Great, thank you. And that kind of ties in. I'm glad you brought up the deepfake and some of the challenges. The work that I essentially do is how to help organizations prevent AI ethics issues from happening, particularly the finance side. But you see whether it's cybersecurity attacks or oftentimes accidental really problems that occur from not understanding the ethical implications of AI. I know Amber had briefly mentioned that as well. So let's shift back again to kind of how you're using AI, and I want to hear what's your favorite project, what's your big impact project with AI in maybe the last year or so. Beth, you want to get us started?
Sure. So I think with us, it's got to be the revenue forecasting model. And it's not just about revenue, it's about what we call them origin and destinations, and figuring out what routes to, based on demand, based on what we're seeing, based on, we modeled in vaccine, like vaccine rates, and we modeled in all kinds of things to sort of predict what's coming back. And it impacts like so many different layers. So you think about, okay, so we're going to launch this new route, or we're going to bring this new route back. So you need to bring back the staff that we put on furlough. You've got to make sure they've got uniforms. You've got to make sure that they've got, that we've got scheduling. We've got to make sure that they've got all the tools they need to be able to support customers through the journey. So it's like, there's so many different places and parts that have an impact on that one decision, or multiple decisions that come out of that one model that the team have built, and constantly kind of updating based on searches. So we hear, whatever, a government will announce something, or there'll be case counts will go up or down, and we can see people's demand and interest. And so then we update that, and then, kind of rerun it again and see what that means, and then readjust all of those forward-looking planning things that we need to do. So, it started out as something where I was like, oh my goodness, how are we going to start? How are we going to do this? And it's a regular cadence every 2 weeks. There's quite a senior group that we kind of review what the model's telling us, what we know, and then kind of everyone goes away and does what they need to do to be able to make it come true, if you will, like try to deliver on what those forecasts are telling us. So I'd say that's probably certainly the last year and a half, that's been by far and away the most impactful.
Very interesting to hear. Kind of like Dr. Atimode said, it's at the end of the day, AI is just a tool, right? It's a better tool, and perhaps a faster, more efficient, but it still is just a tool. You were still doing revenue forecasting, prior. So it's really interesting to see how you've kind of used the technology, but increased or improved the performance significantly, especially during COVID. Back to you, Dr. Atimode. Big impact projects, research or otherwise.
Yeah, so definitely this PPG2ECG project that I talked about is one of my favorites, just because the impact that it could potentially have. And we're actually talking to a couple of companies. There's a number of companies that are interested in getting this tech and into their devices, which we're hoping that could happen and it could save lives. Another one that I'm very excited about is another project where we're collaborating with a company that is interested in creating a happier and healthier workplace for their employees. And so that involves everything from creating these models that could give feedback to people about their physical health in the workplace, things like posture, things like fatigue, physical fatigue, but can also go beyond that and look at things like mental fatigue. And this is actually something that I think many people are experiencing, what we call Zoom fatigue. Going from meeting to meeting to meeting without a minute of break in between is really taking a toll on a lot of people. And this is actually something we're working on right now to create these AI models that could actually monitor your meeting schedule, monitor your discussions in your meetings, and monitor your cognitive load and affective state, and give you feedback without absolutely no sharing with your employer or anything, but directly to you to maybe take a step away and take a walk for 5 minutes, or take some deep breaths, or take a go for a glass of water. So this is something I'm particularly proud of, not only because I think it could help and could have good impact, but also I would be the first user of that tech. I would be the first customer if we could launch it, because I think it could really help people.
I'd be number two. I know actually the Smith School of Business has just joined in a partnership, the Digital Technology Supercluster, with Lululemon and Wisdom AI, as well as the School of Computing, to actually look at kind of wellness chatbots and wellness products. So similar kind of space or similar kind of use, AI for good, and in this case, mental well-being. So to round it out on this topic, Dr. Simpson, big impact projects. I mean, it sounds like you have a huge list, but give us your favorite.
Yeah, so last week we were successful in doing something that's called federated learning. So it's the idea that instead of, so historically, we've always shipped our data around to everyone, right? So if you want to share data, you physically have to share all the data. But there's another way to do that, and that's by just moving the model, which is a much easier thing to do. And it turns out that the agreements and the regulatory around that are so much simpler, because you're not actually sharing patient information, you're sharing essentially weights of models and numbers, and that's it. And so last week we were successful. There's a group of 100 institutions that have come together to solve a single problem in my field. And we actually all got it to work last week by keeping our data local and training these networks across these 100 different sites. And it's been an administrative nightmare to get all of this set up, but it's phenomenal that now this is set up and now we can start really rolling this out and solving fundamental problems.
Wow, I sometimes struggle to get the same model to run correctly twice on my own machine. So that's quite the feat. Congratulations. Very exciting. Let's look a little bit, forward looking with your work. What's kind of your end goal, or perhaps the pie in the sky goal that you have for your work? Perhaps Dr. Etimode, you can kind of share your future research goals.
Sure. So in general, I think if I have to summarize it, it would be just better quality of life. I think that's what we're trying to create with better products. Some of them could be, simple entertainment cases. For example, I'll give you another example of a project that we did. We call it the Effective Music Player. So what we did was we have this interface for playing music, just like Spotify, but it talks to your wearable device, and from your wearable device it gets your heart rhythm, and from that we're able to detect your emotional state. So whether you're stressed or calm or anxious, or different states of emotion, and we're able to feed you the type of music that would suit your mood better, to put you in a better state in general. So this is something that is more for entertainment. It definitely could have implications for well-being and mental health, but it would be pretty small. It wouldn't be significant. But things like that could also play a role in just better quality of life, just better products, better devices. This is what a lot of people are after. And then beyond that, I would say definitely within that, under the umbrella of better quality of life would also be pervasive health monitoring with wearable devices, which is something we're really focused on as well. So we use a lot of wearable technologies for monitoring biological signals that come out of people and apply AI on those, and those could be used for pervasive health monitoring.
That's incredible. Kind of like the building upon the, heart rate monitor that's on the Apple Watch. That's always the one that I think of. Or your fall detectors. Dr. Simpson, end goal.
Yeah,
what
that
you're
was
working towards.
a great segue from Ali. That was perfect.
Yeah.
Improving quality of life. I love this idea of wearables, but also how it connects with our medical records and our really deep data that we have on people. So our genomics and things like that. What I'm really excited, and this is the pie in the sky thing I've been thinking about, is so you saw that article in the Gazette and this idea of mapping cancer across space and time. What I'm really excited about what that potentially means for patients with something called a cancer of unknown origin. So when you get treated with cancer, we try to sequence you. So we take a sample of your tumor and we'll send it for sequencing. But we only do that if we know what kind of cancer you have. Because if you have breast cancer and you're HER2 positive, we know what to do. If you have lung cancer and you're ALK positive, we know what to do. But if we don't know what your cancer is, we don't know what to do with the findings of that test. And so what this beautiful map of cancer progression is going to tell us is it's going to let us map back in time these patients that we didn't know what their primary cancer or their first cancer was. And so if we could do that, if we could figure out what these first cancers were for this group of patients, then in the future we can predict that for a really select group of patients that really have no other treatment options right now. And I think that would just be, that's kind of the holy grail of cancer. Actually, I don't even think it's the holy grail right now because people don't even think it's possible. It's just so out of the realm of possibility they don't even consider it. But I think with AI tools we could actually do it, and I think with that data that we've presented, it's definitely tractable at this point.
Wow, incredible. I'm looking forward to reading that article. So thanks for posting that to Queen's Branches in the chat. Beth, end goal of your work, either at Air Canada or just in general?
Well, coming off the other two, it's hard to, whatever I'm going to say isn't going to quite.
I know. Cancer and
so
we're.
However, I
I'll ask a different question.
yeah, okay, fine. Different question. In the world of, an airline, and my reality, I think the ambition for kind of what drives me forward is I want to turn data at Air Canada into our competitive advantage. Like, I want to get us to a place where we are able to put the right data into the hands of our employees and our teams to inform their decisions. And if that means it's everything from, from an automation perspective, if we can automate a bunch of the not very value-adding tasks, but necessary tasks to free them up to be thinking of the more creative ways to address problems, that's one of them. If we can, use the data and some of the modeling that we're using on one side of the organization and apply it and make it accessible to another part of the organization. Like, to me, one of our team members this last week was sort of saying, like, Beth, we just need, if you do this right, we'll set, data is going to set us free. And I actually think it will. Like, it sort of sets us free from using anecdotal, using, well, we used to do things this way, and actually being able to use some of these models to be able to say and to show and guide us to be able to make informed decisions that are kind of not just based on sample size of 1, not based on sample size of 50, but really based on sample sizes of much, much greater numbers that will inform our decisions. So I still think there's a there is that pie in the sky that if you kind of always have that as your North Star, we're gonna make the right decisions to get us there.
It's interesting to hear that industry perspective. I mean, I used to work in marketing. Funnily enough, I used to manage the brand Lysol. This was prior to the pandemic. Since then, I've been a PhD student, but I remember working there not 4 or 5 years ago, and data wasn't being used for decision making. I mean, we had lots of data, but it just really wasn't being analyzed. And that was one of the reasons I went back to do my master's in analytics, because we hear about all this incredible research being done around AI and around analytics, but sometimes in practice, it's barely being used. So I agree that there's, a lot of vision is sometimes just using the technology, just getting it adopted across the organization is an incredible goal. So I'm interested to hear more in the future as to see where that goes. So I think to kind of wrap up our question section, and then you will have seen in the chat, we have some time for question and answers from the audience. But to wrap up the panel section, could you all kind of provide some advice for people looking to implement artificial intelligence in their work? Either, how can citizens be involved, or how can organizations better use AI and our analytics? So Beth, I'll actually go back to you here as the industry expert. What advice would you have?
Well, I think maybe I'll pick up on what Ellie was saying about, think of it as a tool. I think sometimes the temptation seems to be that we're focusing on the how before you get to the what. What is it? And so, I think the best advice is not sort of say, well, I want an AI project or I want something for AI. It's actually more define what it is that we're looking to achieve, and we'll use whatever tools we can to be able to achieve that. And I think that, there's kind of that's a different mindset, because it means that even if you're starting with something small, you can kind of build and evolve it and make it bigger and bigger and better as you go, because you're always moving forwards. Whereas if you start at the other end, it can be quite daunting, especially, organizations where, there's not an integrated data platform. Like, there's a lot of siloed data. It gets hard to start with a big lofty project. I think it's much better. And certainly what we've learned, and it comes right from, our CEO starting it and saying, yeah, we're going to do this. We're going to invest. We're going to start here. And then, we are growing that practice and our AI practice more each year. So I would say, yeah, start with what it is you're trying to achieve and frame your problem so that, and then, there are lots of great organizations, either internal or lots of partners of people, in academics and elsewhere who can help build it out to be, use all of the evolving techniques in artificial intelligence.
Yeah, absolutely. Leadership buy-in, as you mentioned, being a key, very key one. Dr. Simpson, perhaps not obviously on the industry side, but could you give us a bit of perspective on, how citizens, how individuals can play a role perhaps in the thoughtful use of AI moving forward?
Yeah, for sure. Sorry, my heater just clicked on, and it's a bit of a wind tunnel in here when it does that in Botterill Hall. Yeah, so look, I think when we develop AI and we think of AI, I think it's really important to get out of the silo and to really work with the people that the AI is going to be used for, is going to be used with. So for example, in my work, I work all the time with clinicians. That's why I'm in the hospital all the time. I'm talking to patients. I'm talking to the people that are actually going to be affected by this work, right? If you're doing something that's going to affect Black and Indigenous populations, then you better be working with them on it, right? And I think Beth would probably agree with me on this point, right? Like, if you're going to develop AI and they're developing AI at Air Canada, they better be, working with the customers, which I'm sure they're doing, for it to really be practice changing, for it to really make a difference at the end of the day. You've got to include the right people at the table from the very beginning of the development.
That's great advice, and especially as the ethicist, I think very important. Dr. Ettemode, to finish this off, can you provide your perspective?
Yeah, definitely. So again, I want to emphasize on how AI is a tool like any other, and like any other tool, you need to start with a good problem statement. Start with a problem and find the cheapest tool that could get you the most results. That's usually, at least I know the industry works that way. I spent a few years in the industry before coming to academia, so I'm well trained on starting with a problem and going to a solution as opposed to the other way around. So I think that's really important, and it's really important to figure out problems, but then we could also think about really finding good and important problems to focus on. There are a lot of problems that are really fundamental to the future of the human race, and I really think that if we focus on the right problems, AI can really help. There's a good movement happening right now, and it actually Yoshua Bengio, one of the three godfathers of AI, is one of the huge advocates for this movement, which is to, for example, use AI for tackling big problems as opposed to small problems. And one of the ones that he's focusing on recently is, for example, climate change. So by thinking about big problem, I'm not suggesting that everyone has to be Elon Musk and try to tackle the three biggest threats to human race, but I do think that we can focus on some right problems and try to use AI to at least take a step towards solving them, if not completely solving them.
And another great Montreal call out there, Yoshua Bengio at Université de Montréal. There you go. So big, as Dr. Etimode said, incredible Canadian artificial intelligence researcher. So with that, that wraps up our panel section of this evening. And before we jump into the Q&A, I would just like to thank our panelists, Beth, Quentin, Dr. Amber Simpson, and Dr. Ali Etimode for your involvement this evening. Some really, really interesting stories and examples of how AI or analytics is being used in research and industry, telling us about some of the possible challenges, the barriers to adoption, struggles with retention, struggles with GPU and computation access. And then it was really, really great and inspiring to hear the stories and kind of the pie in the sky. So we have some great links in the chat for those who are interested to learn more. With that, we would like to open it up to the audience for Q&A, and I believe you are able to ask questions through the chat. So we'll give the audience a minute to collect their thoughts, and we'll be monitoring the chat. So please go ahead, and if not, I will ask a few more questions of our audience or of our panelists.
So I think there are, can you see them, Stephanie?
I cannot actually, which might be a technical issue on our end, or on my side. Oh, here we go, Q&A, beautiful. Thank you. So I see the first one for Dr. Etimode, primarily. How do you balance the positive impacts of workplace support through AI with privacy? If the data shows an employee is struggling with mental health issues, could the company find out? How do you ensure this works for good? So to start us off, a great ethical issue.
Yeah, that's a wonderful question, and one that I have had to think about a lot and plan for a lot, and also justify a lot for the funding agencies who have been backing my works over the years. So personally, I actually think for this particular project, these models will run locally on the machine, so they will not be shared with the employer. They will be on the user's machine, and they will only give the notifications to the user. There is no link between that information and the employer, and so the probability of leaking, that information leaking it's not zero, because neither is the probability of your doctor's server leaking and for some people for your employer to get that same information from your doctor. There's no technology out there in any domain that is 100% safe. I'm a firm believer of that, but I think that most of the technologies that we've adopted today we've gradually and step by step made them safer and safer and safer. And now we're at a point where, we have airplanes that are in the sky every day. And I'm sure if we thought about, for example, airplanes back when the first one was invented, the dangers of it would have really outweighed the benefits. But today we see that they're being used on a daily basis, and we're not worried about them falling out of the sky anymore, and they're safe. So I do agree that there are dangers and there are risks, but I think we can definitely work to create secure systems and put regulations in place to make things safe, and just try our best and gradually work our way there. There will be mistakes probably in the way, and some things will happen that shouldn't, but we can try to minimize them. Again, I think there's the chances of our medical data leaking from the health ministry website is not zero. It's definitely not zero. And so we're okay to live with that risk. I think we can also, if we've done things right on the AI perspective, I think we can also reduce the risk there.
Great, thank you. Kind of the balance between innovation and regulation, I think, is often talked about, at least in the ethics area. On the health side as well, I see there's another question. So I think this is for Amber. How does AI deal with or identify some of the input data being bad data? For example, incorrect CT scans in medical sciences, or a misdiagnosis from an X-ray, or even a heart rate is elevated for different reasons, maybe a physiological versus emotional reason.
Yeah, I guess you should keep in mind that medicine itself is flawed, right? And that, and again, the way that we treat people, so they come in, we try to treat them, that doesn't work, so we do something else. So I think, the physician as a definitive person that is absolutely right 100% of the time is not really true, right? Like, that's not really what happens. They try to do their best based on the available information. And typically we use people as ground truth for comparisons with AI, right? So we use human performance as the comparator for AI, whether or not that's the right thing to be done or not. So I think to some degree, I think clinicians worry about that less than maybe the rest of us do. I will say that in general, AI has really cleaned up or is in the process of cleaning up the quality of the data, because hospitals have realized that if they invest in good data, then they get better, they get better results from their AIs. And when I say AI, it can be something very simple, right? The AI could do something very simple, like just help with their scheduling tasks. So if they provide better information, then the scheduling task will work better. It doesn't always have to change the world. Sometimes just reducing the number of clicks that people have to do is good enough, right? So I think AI doesn't have to solve everything, but humans don't really solve everything right now either. So maybe that's okay. I try to just do what's in front of us, right? So try to solve the problem that's in front of us and not worry too much about solving every problem.
If I may, building on that, I think
Please.
there are data quality issues on every type, every environment. I think, the practice of data governance, data quality, data management, those have evolved a lot over the last even 10 years. And so, data integrity is better, but the adage like garbage in, garbage out, it applies whether you're doing an AI model or whether you're just building a nice little table, right? It doesn't matter. So I think that concept of, because it's AI, is there a higher data integrity threshold? Maybe, but I would say anyway, kind of the whole data and analytics, the realm right now is moving towards more data, better data integrity, better ways of when you do the ingestion of your data, you're doing validations, checking, that kind of thing. Like anyway, that's tightening up and getting more and more structured, let's say, or like formalized, similar to what like kind of software design was before.
Yeah, it's true. And 20 years ago, if you asked a physician to do some kind of structured reporting where they were using pull down menus to define their report, they weren't so open to that. But now, people really understand that there's value, and they actually can speed up their reporting if they do that. They can speed it up and get out of there faster, right? And then there's a value of using that data downstream to do something else. So we've seen a big change, and it used to be there was really a backlash about making the data better, but now, if you also consider that a lot of the people that are in medicine now are getting trained at least a little bit in data science or a little bit in AI, so they understand that there's value. So it's really, those physicians are coming to us and saying, oh, well, can we improve this so that we can do these other things downstream? So I feel like the last 10 years, we've come a really long way on data quality.
And I could just add to that one small point, which is we're also in the field of AI, we're on the verge of cracking these new methods that really don't rely on data as much as they used to. So there's this field called semi-supervised learning and also another one called self-supervised learning. Both of these areas are areas that I've been spending a lot of resources on in my group and trying to really develop some know-how in there. And they're really interesting because they try to reduce the reliance on good data a lot, significantly, and they're very effective at it. We've had huge tasks that we're able to get the same performance on with 1% of the data that we would a year ago, just by switching from a fully supervised machine learning system to a self-supervised machine learning system. And that is also another area that could really liberate us from being bounded by data. We would still need some data, but perhaps not as much as 5 years ago.
Wow, sounds like a lot of advances. It's incredible. You said semi and
self-supervised learning. Yeah, so they teach themselves, so they create fake data. The model creates fake data from some data, and then it uses that fake data to train itself. Which is really interesting, and it's very effective, very effective.
I can imagine.
So I'll give you an example. If you have a picture of a cat and you want to do cat versus dog detection, instead of having a million different cat images and a million different dog images, you could take one cat image and rotate it and just label it as cat number 2, rotate a little more, label it as cat number 3, rotate a little more, cat number 4, change the color a little bit, cat number 5, 6, 7, add a little noise, warp it, stretch it, just create all these different cats from that one cat image, and then use all those new fake cats to train itself. And that actually works very effectively.
And probably cost effective. I know
very
at least from an industry standpoint, gathering data is quite a lot. So actually, to go back, there's another question that touches on something Dr. Simpson spoke about, and this is a question for all the panelists. As people who are leading the way on AI, I guess that's all of you. They're not wrong there. You must face some opposition to your work. So how do you deal with this, and how do you bring people on board to using AI? So maybe Amber, you could, we could go back to you first, and then we can go around the table. So facing opposition with working AI, how do you bring people on board?
Yeah, I think you have to get in the weeds with the people that oppose you, right? And it's typically the people that are going to be users of it. And that's why you need to bring them on board from the beginning. I remember in New York, there's tremendous opposition, but then someone would give me some data and I would say, look what I did with this data. And then that would make all the other oncologists jealous. And then they would come to me and say, well, we want you to do that with our data because our data is way better than that person's data. And that was great. That really brought data science into the hospital and helped us push things forward, because people started to see, oh yeah, this does make a difference and we could actually do something with this. And I think that goes back to my earlier point, you got to get them in early and they got to be true partners.
Mm-hmm. Beth, how do you sell people on using AI?
Well, yeah, it's funny. I think it's not at Air Canada. Maybe in other places I work, like the opposition isn't that we don't want to use it. It's the cost, right? So the cost of bringing in, so it's compute power, it's storage, it's all those, it's the skills we have to pay people to do this that is more expensive than your average analyst, because we're bringing in more advanced data scientists and things. And so normally in industry you have to build a business case as to why we're going to make these investments, and some of the upside or the benefit is here's the minimum, but it could grow really high. But that's not how finance works, right? You need to have here's what my benefits are and here's what the cost is going to be. So I think that's probably our biggest barrier. And that's where kind of support right from the top helps, right? Because then it's sort of like, no, we are going this direction. We're going to allocate this amount, especially in a constrained environment that we are in now. It's how do we make sure that we're still moving things forward? We're still putting investment there. At the same time, we can't, we have to be very, very cost conscious in all of our spend. So I think to me, that's interesting. It's not about the threat of AI per se. It's much more about how much are we going to invest? Like how much money do we have to spend to reap the benefits?
Got it. Dr. Etchemout, bringing people along on the AI journey.
Yeah, definitely. I think, show them the good applications, show them that, by using AI, you can optimize airline routes and get them home for Christmas cheaper and faster, show them that you can detect cancer, show them that you can predict cardiovascular problems or predict a heart attack, 20 minutes before it happens. These are all applications of AI that has made life easier. But I also think you can look at it from another perspective. And again, going back to the fact that AI is just another piece of technology. And like any technology, it could be used for bad or it could be used for good. And the right path is not to really limit that technology, but is to have so many good applications for it that it really outweighs all the negative stuff. You think about the first Homo sapiens, the first tool they created. I'm sure it could have been used for hunting or killing the tribe down the jungle, right? And that was the first piece of technology. It could have been used for good or it could have been used for bad, but we're here because we've built on technology after technology after technology. And I think if we want to survive on this planet for another, for thousands of more years, or hundreds or millions of years, we definitely need more advanced technologies and tools. And the right way to do it is just to support the good uses and then not really limit the whole thing.
That's very valuable advice. I think building on that, and perhaps something that Amber said as well, which was, bringing in your stakeholders, who you're working with, the users, the people affected by the outcome, but in the design as well. I mean, I always, on the ethics side, we always think about diversity in your development team. So you're talking to your stakeholders, you're talking, involving people from different demographics, we might traditionally think, but different psychographics and different expertise. So the more people kind of involved in the project ideation is often a way to decrease the opposition, essentially because you're able to come up and think about the problem, at the beginning before you get too far down the line. So at least from the ethics side, the diversity is key there. So I think perhaps our last question, at least the one that we have up, again for the whole panel, what advice would you give to individuals looking to reskill or learn some of these AI skills, particularly if their education background is not in the STEM area? So how can we empower ourselves if this type of work is, not in our wheelhouse? I think that's an incredible question. Does somebody want to jump off? I'll open up the floor.
I can start.
Sure.
So when, certainly with us, but I'm sure many other places in a agile development approach, you have all different types of skills that need to. So yes, there are some, very technical and STEM type roles, but there are lots of others who are involved, who support along the way. And so everything from, kind of translating the business need into a little bit more of a problem description and a little bit more of a business requirement documentation. We call them the business analysts. Like, you need that in order to be able to properly articulate the problem to help kind of define the work. Then, kind of a little bit farther down, you have Scrum Masters and kind of people who are coordinating all of the work within our design pods. They don't need to be technical per se. They need to have a curiosity and interest and a willingness to learn, but they don't need to be the ones who are doing the actual coding and modeling themselves. So I think it might be different in academia, but in industry, like we're not everybody are all STEM related. And then the more you learn, I've got people on my team who started out as business analysts, then they become data analysts, which is kind of the next level, more technical, because they take courses and they're that curious and they want to learn, and then, you know, they kind of go from there. So, you know, I would say that you can be on the AI train or the advanced analytics train, and you don't have to be, or let's call it plane, because you could be on that plane, but you don't have to be, you know, necessarily just the, you know, the advanced modelers and analytic people.
That's great. Thanks for getting us started, Beth. Dr. Simpson.
So to plug Queen's a little bit here, so we've actually started a minor in AI. So it's a Bachelor of Arts with a minor in AI, and that's really designed for folks from the humanities to get into AI, which I think is phenomenal. Obviously, Stephanie, you come from the School of Business that has been really great at and masterful at creating programs around analytics for folks that don't have a computer science background. And then in health sciences, we're doing the same thing. We want to replace first year calculus with data science, because I can tell you that I don't use integrals very much, but I do use data science quite a lot. So thinking about, you know, that would really fundamentally influence everybody that gets trained in medicine, right? And so I think that's phenomenal. But I think Queen's really wants to think about, how can everyone do AI? Every Queen's student should be able to do AI in some capacity and should be able to understand it and critique it.
It's a great plug. Thank you for that. Dr. Edmode.
Yeah, so I completely agree. I think not everyone will have to be or could be an AI scientist and actually write code and develop models. I don't think that's reasonable or sustainable even for the world and for the workforce that we have. But I think, you know, the state of AI is in a, right now we're in a state in AI that we do need what we call domain knowledge or domain expertise to guide the development of AI models. So I'll give you an anecdotal example on this. Before, like I said, before coming to Queen's, I spent some years in the industry, and one of the places I worked in, we were developing wearable devices for cyclists. So the goal was to create this virtual coach or this wearable coach that would monitor your cycling patterns and give you coaching feedback on better balance, better push and pull with quadriceps and hamstring to enhance your performance. And so I was responsible for the AI, but I know nothing about cycling and nothing about the quadriceps and nothing about lactic acid and all the things that cyclists really care about. And so we hired a in-house pro cyclist who had gold medals and who has done very well in their own field. And their job was to help us develop better AI models. So to inject domain knowledge, domain expertise into the AI systems that we were building. And so this is another area where I think, you know, non-AI experts can really have an impact in the outcome of AI systems. Yeah.
And a cool story to boot. So we do actually have another question, and it perhaps will let us finish on a bit of a comic end. But the question for the panelists is, have you ever had results that made you laugh or really scratch your head that you'd like to share? Perhaps models giving you funny results. Beth, I don't know whether perhaps on the Air Canada side or just stories. You might have one. Amber? I know, I'm trying to think. It's probably a lot.
So sure, I have one. So I used to spend a lot of time with oncologists and surgeons on a very, very daily basis. And I remember one of the surgeons that I was working with, we had this idea for this thing, and the surgeon said to me, Amber, I don't need your AI to tell me blah, 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 blah. I can just look at the patient's ankles, because, you know, and this has to do with if you're diabetic or if you're having mobility issues, all of these other things, these are also comorbidities for cancer, right? So he was like, I just have to look at the ankles. He said, I don't need any of this. I can just look at the person's CT scan myself, look at their ankles, and this is all fine. I don't need it. So I said, okay, great, we're going to study that. So we did a whole study about it, and we compared the AI to how physicians and surgeons would do by just looking at the same information. And so actually the AI did very well, but the most outstanding radiologists that we had could do better than the AI. And we kind of knew that because he's really, really good at what he does. And so I thought it was fascinating that, Gestalt is a thing, and it's a measurable thing, and people get really good at something and they can do it. But it's also all in the ankles. So I don't know, Ali, you need to come up with a monitor that we can slap on people's ankles, because that's going to be the next wave for the Apple Watch.
The ankle watch, the anklet.
Yeah, maybe we put it on our ankle.
My ankle. Yeah.
We'll just get that.
Yeah, I have one. We were working on a project where our goal was to take regular photos of objects and people and whatever, and generate a depth map for them. So there are two types of imaging modalities. There's our regular red, green, blue, our regular images, which we call RGB, and then we have depth sensors, which actually measure depth. And a lot of cars, to do autonomous driving, they require both. So they fuse that information to get a better sense of the world, because we're also measuring depth in our eyes, because we have two of them. We can actually measure depth in an implicit way. We're not like doing the calculation in our head, but our brain actually perceives depth, right? So we were trying to take the regular RGB images and actually use, again, deepfake technologies to generate the depth without actually having a depth sensor, so that we can bring down the cost for self-driving cars, for example. They wouldn't need all these expensive sensors. They would just need a camera. And so we collected, we have these online data sets that we're using. They're all public. They have both RGB images and they have depth images, and we train a deepfake, or again, generative adversarial network, which is again the engine behind the deepfakes. And we wanted to convert these RGB to depth images. And so usually when you do something like that, the quality of the output, which in this case was the depth, would be subpar to the actual thing, because you generally try to match the depth. Like your end goal is to get depth images as good as your actual ground truth data. And in this particular case, the results were actually better. So we got depth images that were actually higher in quality and would work much, much better for measuring depth than the actual real images, which was completely unexpected. And we're still scratching our heads on how that happened. We got this peer reviewed, and it was very well received, and it was very interesting.
That would be an interesting position as a reviewer. I always think, wow, these results are really interesting, but goodness knows how we came across them. Well, perhaps end on that magic of AI note. That's pretty cool to hear how the technology is being applied. So again, thank you so much to our panelists, Beth, Amber, and Ali. Just real pleasure this evening. And I think with that, I will hand it back over to Geneviève to wrap up the event.
Thank you so much, Stephanie. I was still looking at my ankles to see what they should be telling me. So thank you for the tip. So we're almost at the end of the event. So on behalf of the whole Montreal Alumni Branch, I'd like to give special thanks you to our moderator, Stephanie Kelly. You've done an outstanding job. You kept us on our toes for the whole hour and a half. Thank you. As well as our panelists, so Dr. Ali Edemad, Beth Quinton, Dr. Amber Simpson, and of course also Queen's representative, Lee Kalin, for their participation. Of course, also a huge thank you to Roger Casgrain and his wife Colette Charret for their support of the branch and of Queen's. So before we say goodbye tonight, there's a few special housekeeping items. So I'm pretty sure everybody wrote a note to look at the different programs offered by Queen's in the AI space or analytics space. So that's in my agenda for early tomorrow morning. I'm looking to perhaps pursue further higher education. But there's a few more items. So we're always looking for volunteers and fresh ideas with the Montreal branch. So if anybody on the call is interested to participate and volunteer, we'll share after the meeting an email address where you can raise your hand. We love to have more diversity of opinions and new ideas. There's also an opportunity for alumni who are with us who might be from a different branch to volunteer. So we'll share that email address as well in case you want to raise your hand. And the last piece of information. So because we want to hear more about what matters to you, potential new events, questions and ideas, there will be a survey that will be deployed within a few days. So we'd like you to fill it up so that you can really have an influence on our future alumni events. So that would mean a lot to us. So again, thank you so much everyone for your participation, and have a great rest of the evening. Thank you.